I've got another question up here, same directions as last time. We want to complete the square to get it into vertex form, and then graph it including the vertex and all of the intercepts. What makes this one a little bit more complicated is that the coefficient in front of x squared, which we're calling a, which will be the same a that we get in our vertex form, is not 1. So the first thing I'm going to want to do is factor that out. But if you remember, we looked at the number that we had last time and we sort of said that's probably the wrong number. I know that when I look at x plus d squared, which is x plus d times x plus d, that's going to give me x squared plus 2 copies of dx plus d squared. The number I'm going to want there is whatever d was squared, and that's probably the wrong number. So we sort of separated that out. That is going to get adjusted and ultimately become, after adjustment, our k. So we said, let's look at negative 3x squared plus 3x plus 6. Let's sort of shove it off to the side. We're hoping to modify this to make this match our perfect square. So what I'm going to do is I'm going to factor out that negative 3, because I find it a whole lot easier to complete the square when I want just one copy of x squared. So I'm going to factor out my negative 3, and that's times x squared minus x. But that 6 is just kind of hanging off to the side. Okay. I could factor out the negative 3 from that if I wanted to. Don't need to. In this particular case, 3 factors out nicely. But I could have something like a 7 there, and then if I factored out the 3, I'd have fractions. I think it's easier to just let the constant sort of hang out off to the side. What I want to do now is try to work with what I've got in the parentheses here to try to complete the square. So that I'm hoping to get negative 3 times, I can manipulate this to make it match to be a perfect square, and then plus a number, and probably in the process of manipulating this, this number is going to change. Let's see how that works. Okay. So by factoring out the negative 3 here, I've made it so that I have 1 copy of x squared, which is what I want. Now if I look at the number of x's that I want to have 2d. If I look at the number of x's that I have negative 1. Notice the sign is considered part of that coefficient. So if I'm hoping that these first 2 terms here match these terms here, in order for that to work, d would have to equal negative 1/2. With that choice of d, these 2 terms are the first terms in this formula for a perfect square. So then the number that I would want would be a d squared, which would be a positive 1/4. So I'd like to add on a 1/4, but I can only do that if I also subtract a 1/4. So that's going to be negative 3 times x squared minus x minus a 4th plus a 4th, close parentheses, plus 6. Very, very important that both the both the positive 1/4 and the negative 1/4, I wanted to add it and then also subtract it. Very important that both of those are in these parentheses, because I'm multiplying these first 2 terms by negative 3. I've got to multiply everything by a negative 3. But that means that I'm not really adding 1/4 here, I'm adding negative 3/4, because I'm going to end up multiplying this by negative 3. So I need to not just subtract 1/4, I need to actually add 3/4 in order to undo that. Here I'm adding a 1/4 that will get multiplied by a negative 3. I need to make sure that the negative 1/4 is also being multiplied by negative 3 so that I really am just adding 0. Now, I set it up so that these 3 terms match my formula for a perfect square. So this is sort of extraneous. So at this point, I'm going to distribute back in that negative 3. But I'm not going to distribute it to each term one at a time. I'm going to distribute it to my 2 groups. Negative 3 times my perfect square, x squared minus x plus 1/4, and then negative 3 times negative 1/4, which becomes plus 3/4, and then plus 6, which I'm going to just write as 24 fourths. So the extra number here ended up being 3 fourths. So now I can say this is negative 3 times x, and this factors now as x minus 1/2 squared. My d was negative 1/2, so x plus d is x minus 1/2, and then plus 27 fourths. Excellent. Okay, so we now have this in vertex form. So I can read off from here the coordinates of my vertex. The number I'm subtracting from x is 1/2. The number I'm adding after I square is 27 fourths. Now I might want to just rewrite that as this is 6 3 fourths, because that's going to help me in plotting it. So 1, 2, 3, 4, 5, 6, 7. So here would be 1/2, 6 3/4. I'm just going to label it as 27 fourths. You can label it as either the improper fraction or the mixed number. Excellent. Now, this parabola is going to open down. That's because I'm multiplying by a negative 3, so it's opening down. So I can see it's going to hit the x-axis. So I'm going to have both x and y intercepts. Let's go ahead and find the y-intercept first. I think that's a little bit faster. Notice I can actually use either version of my formula here for finding the intercept. I know I need to plug in 0 because I'm going to be getting the point 0 f of 0. I think I'd rather plug in 0 here than here because there's less to do. If I plug in 0 here, all the places where I'm plugging in 0 just go to 0. I'm going to get 6. So my y-intercept is at 0, 6. Now, if I plugged in 0 here, I would get exactly the same thing. I would get 0 minus 1/2 would be negative 1/2. Squared would be 1/4. Times negative 3 would be negative 3 fourths. Plus 27 fourths would be 24 fourths, which is 6. I just get it a lot faster there. So there's a little bit of strategy when you've got multiple versions of your formula. Okay. Then I want to get my x-intercepts, and there will be some here. Now, I can use either version of the formula for finding my x-intercepts as well. I'm going to go ahead and just review how to find them using this version of the formula so that we can review how to solve by taking square roots. Later on, we'll be solving by setting this equal to 0 and either factoring or using the quadratic formula. So we'll be reviewing it both ways. And if you prefer to use the other version, you certainly can. Okay. So I'm looking for where does 0 equal negative 3 times x minus 1/2 squared plus 27 fourths. So I'm going to subtract this over. So negative 27 fourths would equal negative 3 times x minus 1/2 squared. I'm going to divide both sides by a negative 3. Notice that's the same as multiplying by negative 1/3. Okay. So the negatives here cancel. I get 9 fourths equals x minus 1/2 squared. Now that I've isolated the square, I can solve this by taking the square root of both sides. So the square root of 9 fourths is equal to the square root of x minus 1/2 squared. With a fraction, I just take the square root of the top over the square root of the bottom. So that's going to be 3/2 is equal to the absolute value of x minus 1/2. Don't forget, the square root of something squared is the absolute value. So x minus 1/2 is plus or minus 3/2. Now to solve for x, I'm going to want to add over that 1/2. The last time we had to do this, we had unlike terms because we had a square root that didn't simplify over here, and we had, I think, an integer over here. But here, these guys are both just fractions. They're like terms. So I can do the arithmetic. When that's the case, I'm going to have to split this up into two problems. So either 3/2 equals x minus 1/2 or negative 3/2 equals x minus 1/2. Okay. I'm going to get different arithmetic problems with 3/2 and negative 3/2, so I do have to write them separately. Now I can add the 1/2. That's going to give me x would equal 4/2, which is just 2. Here, when I add the 1/2, I'm going to get x equals negative 2/2, which is just negative 1. So my x-intercepts, I've got the x values of them now. They're going to be at 2, 0, and negative 1, 0. Whoops. Sorry, negative 1, 0. And so now I can connect the dots, and that's going to give me my parabola. Okay, before you tune into the next video, I want you to try a problem. Now what I've done is I've chosen one of the homework problems. Okay? I'm trying to add an incentive to really actually take this seriously and do the problems. Okay? So if you're like, oh, you know, I just want to get done with these videos so I can do the homework, this is a homework problem. This is homework problem number 19. You're looking at f of x equals negative 2x squared minus 10x plus 4. Same directions, complete the square, graph it to get it in vertex form, graph it including the vertex and all of the intercepts. And then the homework asks for a couple of additional things. So let me make sure I give you all of the directions. Write it in vertex form, identify the vertex and the intercept, sketch it. Okay. Also going to ask for the axis of symmetry. It's going to ask for the value of the max for the min. So with that, tell me whether it's a max or a min, and then give me the value of it. Notice the book's only asking for the value of it, not the location. Make sure you answer the question that's asked. And then give me the domain and the range in interval notation. So try that with this problem. You're getting a head start on the homework, and the next video will start by going over that together.